Hi, I'm an old guy and I do maths, and today we're looking at radians involving improper fractions, calculation of values, I guess it comes down to. Um, so let's start with this 6 pi on 4. Well, immediately we can simplify that to 3 pi on 2. Pi on 4 is 45 degrees. 6 lots of 45 degrees gives us, what, 270 degrees? Yeah, 270 degrees. 3 lots of 90 degrees gives us the same. That's that. We can find that on a unit circle, and I don't know if we're solving for sine, cosine, or tangent. We can figure out what that equals. 11 pi on 3. Well, how do you deal with this? How do you find this simply on a unit circle? Well, pi on 3 is 60 degrees, and 11 of those will be 660 degrees. 11 sixes are 66. Now, what does that mean? What does that mean in real terms? Well, what it means in real terms is that you're spinning around the unit circle a couple of times before you get to your 660 degrees. So really, the sensible thing to do would be to subtract the equivalent of 2 pi. And how do you do that? Well, 6 pi on 3. That's 2 pi. And that gives us 5 pi on 3. Now, 5 pi on 3 is 5 lots of pi on 3, 5 lots of 60 degrees. And that's going to equal, 6 fives are 30, that's going to equal 300 degrees. I should put up here that this equals 270 degrees as well. And this is a key thing. And it's going to be something that we'll look at in a couple of further examples. But effectively, what I've done is I've subtracted one entire circuit of the unit circle, effectively 2 pi. This is 2 pi up here. Okay? That's how I get my 300 degrees. Okay, 13 pi on 4. Well, again, we're looking at going around the unit circle a couple of times, or at least 1 and a bit times. So let's see if we can tidy this up. We're going to take the equivalent of 2 pi off this, which will be 8 pi on 4. What does that leave us with? Well, 13 minus 8 is 7. We're going to have 7 pi on 4. That's going to give us something that we can work with. It's going to be 315 degrees. Let me just draw that in here. It's going to be over here. That's a really bad drawing. Unit circle there. So 1 pi on 4, 2 pi on 4, 3 pi on 4, 4 pi on 4, 5 pi on 4, 6 pi on 4, 7 pi on 4. Or if you want to think about it, 8 pi on 4 minus 1 pi on 4. I don't really mind how you think about it. It's 315 degrees. That's how it's calculated. 15 pi on 3. A similar problem to the one we had up here, but let's just see how this unfolds. So if we take the equivalent of 2 pi off this, 6 pi on 3, what we get is we get 9 pi on 3. Now that is still more than one trip round the unit circle. 6 pi on 3 is one entire trip round the unit circle. So we can take another 6 off that if we want, or we could simply have taken 12 pi on 3 off this, the equivalent of 4 pi. Anyway, we take 6 pi on 3 off this, and we get 3 pi on 3, which equals pi, which equals 180 degrees. Again, I think I might just draw this now. Let's start here. We're looking for 15 pi on 3. There is 6 pi on 3 to there. There is 12 pi on 3 to there. And there is 1, 2, 3 pi on 3 to there. That's how we get to that. Okay, well, that's a short outline of how to deal with these radian problems when you have seriously improper fractions to deal with. I hope you found this useful. If you did, please like and subscribe, and I'll see you next time. Bye.